Okay, so this is module number 1. We're going to work at connecting generators to the grid. So in our last section, we left off by running some generators, and now what we'd like to do is connect them electrically. So we're going to talk through the process for doing that. Okay, so let's say we've got a generator and we want to use that to supply electricity to a consumer. Well, we use some sort of distribution grid. Okay, so that might be wires going outside of the plant to the consumer. It might also be inside of the plant, so direct connection from the generator to the consumer. But we should have a fairly simple pathway. The generator can supply electricity to the consumer. Now, it can become more complicated by, adding in another generator, so they have to work together. Or else we could have multiple consumers, so we all of a sudden, by adding in more components to the system, create a little more complicated setup. And so we need to understand how all of these things work together in order to be able to connect them. Okay. Just a little bit of background theory. We have what's known as alternating current. And what that means is that we have electrons that are sitting inside of a wire, and they essentially are pushed and pulled back and forth. So they don't move or flow down the wire. They just sit in one place, but they're oscillated back and forth. In Canada, in many parts of the world, we have essentially a fixed frequency. And what we consider is that those electrons are pushed and pulled back and forth 60 times a second. And that would be known as the frequency. So 60 hertz, 60 times per second, is how many times that oscillation happens. We also have voltage, and if we were to plot voltage versus time, we'd get a sine wave. And so that's what it looks like, that push and pull, although we represent voltage as essentially an up and down. We have what's known as the time period, so the amount of time one cycle takes, so a complete push and pull. And that's related to our frequency. Period is the inverse of hertz, or inverse of hertz is going to be our time period. So in this case, if it's 60 hertz, that time would be 1/60th of a second. If we look at the voltages, we have voltage that's used consistently in different areas of the industry. So one of the most common ones that we might see is 120 volts. That would be our normal household electrical voltage. You'll cover this in electrical, but 120 isn't really the peak. It's an average voltage of the pushes or an average voltage of the pull, and your peak would be 170. However, we would call that a 120 volt system. Don't worry too much about the electrical. It's not really the scope of this course in terms of voltages. However, just note that when we do our simulation, we're going to be running off of a 440 volt system as opposed to a 120 volt system or a 240 volt system. But it doesn't really matter which voltage we use. The principles are all going to be the same. Okay. When we get to the idea of synchronizing, we have these waveforms, and synchronizing is us connecting these waveforms together. So if we're going to have multiple things that are operating in our grid or our electrical system, they all have to be operating the same. So they have to be all compatible with each other. So let's just see what happens if things go wrong. What if our waveforms don't match? So one that's going to be probably our most important is what happens if we have an issue with our frequency. Okay, and we may consider that we have an issue with our frequency where we have one waveform that's moving at 60 hertz or so, and we have another one that's moving faster. Okay, and we can think about these things as being related to mechanical gears. And if we think about mechanical gears, they've got teeth and they need to mesh in order to be able to rotate. Okay? And so when we talk about these gears, we could think about, well, what would it look like if I had teeth that look like this? So I have my normal yellow gear, and then I have a gear with a much more dense arrangement of teeth. Are they going to match and mesh together? No. So in order to be able to make these things work and be compatible, what I need to do is adjust my frequency. And what I'm doing is essentially changing the shape of that gear or changing my waveform. And we'll use a component known as the governor to do that. Okay. The other thing that we might have is a voltage issue. So we don't have the right voltage. And what our waveform might look like is we have one waveform and we have then another waveform that's substantially taller or shorter. And what it might look like if we were to give it an equivalent of gears is we have a normal gear and then we have a gear with teeth that are very tall. And those gears are not going to fit together correctly. And so we're going to have to adjust our voltage, and we would do that using another tool known as the excitation. Okay. So assuming that we have our frequency and our voltage correct, we should be pretty close to having gears that can match together, or our waveforms that are compatible. And so here I have two gears that have matched, which in essence means I have the voltage that is correct and I have my frequency that's correct. Okay. And not only those things, but we also have to be considerate about what is the position of the teeth, or what is the arrangement of the waveform. So if I try to connect my gears together and the teeth weren't in the right position, then I'm going to create a problem. So we have to avoid that. Ideally, what we want when we put these things together is for the frequency to be the same. Okay, so that would be the ideal situation. My generator and my grid are both operating at the same frequency. And that causes me a bit of a problem. And the problem that it can create is that if they're operating at the exact same frequency, there's never an opportunity for those positions to slightly change relative to each other. So I want there to be some changes that happen relative to each other by having a slight difference in frequency. So then the question would be, do I want to have the generator going faster, or do I want it going slower than what I'm trying to connect to? And what I want is for that generator to be able to transfer energy to the grid. So I want my generator to be going slightly faster, so it's at a slightly higher energy level than what I'm connecting to. So in essence, it's going to be able to push electrons through. But there is a limit to that. I don't want that generator to be going very fast or significantly faster than the grid. And the reason why I don't want it to go significantly faster is that we have to connect them, and when they mesh together, they're going to be operating at the same speed. So if there's a significant difference in the speed of one gear or one waveform compared to the other, when they lock together, I'm going to have a substantial deceleration or acceleration in order for them to mesh. So if they're going too fast, I could possibly damage my equipment through large accelerations. So I'm going to use a tool known as the Synchroscope to figure out where the position is correct. Okay, the Synchroscope tells us the relative positions of those waveforms. So as those waveforms are trying to line up to be able to be connected, the Synchroscope is going to tell us when is the right position. And you're going to see a red dot on your Synchroscope. Okay, your Synchroscope's going to indicate for you where that positioning is. And in general, that red dot is going to circulate around in a circle. And if it's going in the clockwise direction, that's a good thing. It means the generator is going slightly faster, or it's going faster than the grid. Okay. And what we want to do is find out where is the correct time. Well, we have positions. The bottom position is the incorrect position, and what it would look like would be the teeth are absolutely not lined up. Okay, or the waves. And if it's at the very top, that's where those teeth are in the correct position. So when we have that red dot that makes its way to the top of the Synchroscope, and it's done it by moving in a clockwise direction through the Synchroscope, that's where we want to connect the breaker in order to connect our generator to our electrical system. Why don't we take a look at that as a little demo with the simulator and give it a try. Okay, so I have my simulator running, and what I'm going to do is I'm going to demo the connection of a generator. Okay, the synchronization of a generator. So I'm going to use this turbo generator, this TG, as my generator that I'd like to connect. And we can see right now I have a breaker that is open, and I'm going to connect it and allow electricity to flow out to the grid. And I'm going to take note of a few things. I have an electrical system that right now is operating at 438 volts. And my frequency is 60.25. Now, I said our frequency was 60, but it can vary a little bit. All right, so the frequency is never locked in. It will adjust, and same with the voltage. So whatever that frequency and voltage is what I'm going to be targeting as my frequency and voltage that I want for my waveform. Okay, so if I look at my generator right now, I don't have anything. I have voltage of 0 and frequency of 0. And the reason for that is that I need to turn on my generator. So I have my voltage controller here, and I'm going to turn it on. And your value might be anywhere from 0 to 100%. When I do connect it on, though, I can see that I have some data. Okay. First thing that I have is my frequency. Okay. We're going to adjust that on a different screen, although I do have a governor here that I could use to raise and lower it. And I also have a voltage. Okay. And I have a voltage here. And again, I have a voltage controller that I could adjust, and I could adjust my value here. It's set at 40% right now. And I could adjust that, but I'm going to do that on a different screen. Okay. And the screen that I'm going to go to, because I can't, I'm going to go to a different screen because if I try to use this breaker, we can see that I don't have any connection button. Okay. Where that connection button is in my panel directory. So if I click on panel directory, and this was my turbo generator, so I'm going to go to 144. But you have different generators, so diesel generator number 1 and 2. For instance, you've got a few different panels. Okay, so this is my turbo generator panel, and first thing that I would do, I did it on the other page, but I turned on my excitation. Okay, and that's going to allow my turbo generator generator component to give me data. So if it's off, we can see I don't have any data. This is a 3-phase power system, which means that I have to measure voltage between 2 of the phases. So by clicking on any of these buttons, I'm able to read what my voltage is. So it doesn't matter which one I pick, as long as they're all balanced, which they should be. I'll be able to read my voltage through any of those. Okay, so I know I have two things that I'm going to have to adjust. My frequency was 60.25 was my bus frequency, so I'm high, which is, I think, a good thing, but I think I'm a little bit high. And my voltage is pretty close. I'm just a small bit below. How I can know where my targets are is if I click on the word Synchroscope. I'm going to bring up my Synchroscope. Okay, so that was that little gauge that we looked at. I'm going to switch to TG, so this is my generator. And we can see I've got my red dot that's floating around. Okay. I have two indicators on my Synchroscope. I have a frequency and I have a voltage. So my voltage is pretty close. I'm a little bit below, but the Synchroscope is telling me that I'm well within range. However, it's also indicating that my frequency is not. And if I look at my gauges here, I have my generator frequency compared to my bus frequency. And I believe my generator frequency is probably high. So I'm going to reduce it. And I do that over here at the governor. So the governor is going to decrease the amount of steam going through this turbo generator. And when it does that, you can see that my frequency is starting to drop. It is slowing down. The governor is a little goofy how it operates. You have to click it on and click it off, all with left clicks, all on the decrease button. And I want to bring that down until I get to a point where my frequency light turns on. And when the frequency light turns on, what it tells me is that my waveforms are now compatible. So my voltage is good and my frequency is good. So the only thing that's left is the timing to connect these breakers. And we would do that using the circuit breaker. Okay? And we're going to connect our circuit breaker, but we want to be very careful when we do that. We want to make sure we do that when the timing is correct. Okay? And we remember from our Synchroscope that when it's at the very top, that's the correct timing. And just because it is rotating, I want to do it just a little bit before. So click. And now I've connected my breaker while the dot was in the green zone, or say between the 11 and 12 o'clock position. And now my generator has connected. It was previously at 60.35, but now essentially those gears have meshed together, or the waveforms have locked in together. My generator is now connected to my electrical system that operates at 60.25. Because this generator was moving a little faster than the grid was, what we see now is that our power from the turbine, it's producing a little bit of power. So it is pushing or pulling some of those electrons that are in the grid. And if I was to adjust my governor at this point, so increase or decrease, I could adjust how much power. So if I increased it, my frequency isn't going to increase because that generator has locked the electrical system. But what we see is that my output power from that device starts to increase. Okay, so you have some activities to do at practicing synchronizing some generators in your simulation activities this week. Okay,